Mars, the red planet. Robot explorers have landed, sending us pictures of a desolate landscape, yet strangely beautiful. Our story begins with a formation known as the Inca City. Discovered in the 1970s, its geometric shapes made people wonder if ancient civilizations once existed on Mars. Mars has been shaped by billions of years of geological activity. Volcanic dikes and asteroid impacts have created formations that look like ancient ruins. Asteroid impacts have left huge craters and rivers of melted rock. These events formed shapes that can look like walls or roads. Erosion, caused by water a long time ago and winds blowing today, shapes Mars. The wind with erosion carves intricate designs, creating formations like the Inca City. High-resolution images show us Inca City. These are mesas formed by erosion. The lines we see are fractures. They were widened by the wind, and maybe also by water. The Martian canvas, painted with rusty ochre and golden tones, tells us a story of a vibrant past, full of geological activity. These color differences give scientists important clues about the history of Inca City and the whole area around it. Today, Martian winds sculpt the landscape, creating dunes and carving grooves. Wind erosion is responsible for the amazing features of Inca City. Inca City stands as a testament to natural processes that seem intelligently designed. It's a window into Mars's distant past, showing us the planet's dynamic history. Our exploration of Mars took a giant leap forward with the arrival of Perseverance, an incredibly sophisticated robotic explorer, in February of 2021. This intrepid rover, equipped with super-advanced instruments, landed in Jezero Crater, a site carefully chosen for its scientific importance. Jezero Crater is believed to have once been a huge lake fed by ancient rivers, and it's very likely that it holds clues about whether Mars could have been habitable in the past. Perseverance, with its 6 wheels and tireless energy, has embarked on a mission to uncover the secrets hidden in the ancient rocks and sediments of Jezero Crater. Its main goal is to search for signs of past life, like microscopic fossils that might indicate that Mars once had organisms, even very simple ones. But the rover's mission doesn't stop there. It also has to study the geology, climate, and the planet's potential for future human exploration. Perseverance has a drill that can bore into the Martian surface. With it, it's collecting rock and soil samples, storing them in sealed tubes to be brought back to Earth on a future mission. When these samples are analyzed in Earth's laboratories, they will give scientists valuable information about Mars's geological history, allowing them to reconstruct what the planet was like long ago in great detail. But Perseverance isn't just a rock collector. It's like a mobile laboratory, with instruments that allow it to analyze the composition of Martian rocks and soil right there on the spot. One of the most amazing things about the rover is that it can make oxygen from the Martian atmosphere. This technology could be really important for future human missions to the Red Planet because it would provide air to breathe and fuel for rockets. Among Perseverance's many discoveries, there's one that stands out for its potential to tell us the story of water on Mars. The rover stumbled upon a peculiar rock called Silver Mountain, whose textures and composition have scientists very intrigued. This simple rock, seemingly just another piece of the Martian puzzle, holds clues to a time when water flowed freely across the planet's surface, shaping its landscapes and, possibly, giving rise to life. Silver Mountain is what geologists call a sedimentary rock, a type of rock that forms from the accumulation of very fine sediments, usually clay and silt, in an environment with water. The layered structure of the rock, visible even to the rover's cameras, tells us about a deposition process, where each layer represents a different moment in time, like the pages of a history book. These layers, formed over many years as sediments settled in the ancient lake that filled Jezero Crater, hold information about the environmental conditions of that time. Scientists believe that Silver Mountain dates back to the Noachian period, a time about 4 billion years ago, when Mars was much warmer and wetter than it is now. During that period, Jezero Crater was a lake teeming with life, fed by rivers carrying sediments from the surrounding highlands. As these sediments settled at the bottom of the lake, they formed layers, trapping organic molecules and minerals that could give us clues about the possibility of life on early Mars. The discovery of Silver Mountain is a very important step in understanding the history of Mars. It confirms that there was water flowing freely on Mars, creating environments that could have been suitable for life. And although we still don't know if there was life on Mars, Silver Mountain and its secrets give us an exciting glimpse into a time when the red planet had the potential to be a world full of water and life, perhaps even the cradle of life itself. Section 3. Martian Mysteries, St. Paul's Bay. Perseverance's journey through Jezero Crater has been like a tapestry of discoveries. Each finding adds a new thread to the story of Mars. One very curious observation has left scientists scratching their heads. It's a formation called St. Paul's Bay because it looks like a port on a map of Earth. This formation, with hundreds of dark little balls stuck in lighter rock, has sparked a lot of curiosity. These spheres, some round, others long or angled, vary in size, from grains of sand to small pebbles. Their dark color stands out against the light rock, creating a pattern that has caught the attention of scientists and the public. What are these spheres? How did they form? What do they tell us about the geology of Jezero Crater? There are several ideas about the origin of these Martian marbles. One possibility is that they are concretions, little balls of minerals that form inside rocks when groundwater seeps in, leaving minerals around a center. Concretions are common on Earth, in different shapes and sizes. If they are on Mars, water played an important role on the planet's surface. Another possibility is that they are volcanic in origin, formed from molten rock or lava. Volcanic rocks have many textures and structures. Perhaps these spheres are a type of volcanic rock or cooled lava. Analyzing the composition of the spheres will be key to knowing their origin. Section 1. Lessons from a Silent World. Inca City, Silver Mountain, St. Paul's Bay. These names, reminding us of places on Earth, make us think about something very important. Exploring Mars isn't just about uncovering the secrets of another planet, but also about understanding ourselves better. By trying to discover if we are alone in the universe, we encounter the immensity of geological time, the power of nature, and the limits of what we can understand. The formations that once seemed made by ancient Martian civilizations, we now know were created by volcanoes, wind, and water. This teaches us how important science is, to test our ideas with evidence, even if this evidence goes against what we believed. Searching for life beyond Earth is exciting. It fills us with curiosity, but we have to be careful and methodical so as not to confuse something that seems familiar to us with something truly extraordinary. Even though we use science, we also have to use our imagination, that desire we have to explore the unknown, to look for patterns and understand the universe. That desire has taken us from Africa to the moon, and someday it will take us to Mars. What we have learned from Inca City and other Martian formations is not just about geology. It teaches us about the human spirit, our capacity to be amazed and to doubt, to dream and to do. It reminds us that the universe is full of surprises, that our place in it is special but also fragile, and that by trying to understand the cosmos, we are understanding ourselves. Section 2. Footprints on Mars. A future beckons. As we delve into the mysteries of Mars, each discovery paves the way for a future where humans can walk on the red planet, not just as visitors, but as explorers, pioneers, and maybe even as settlers. What we learn from missions like Perseverance, from analyzing Martian rocks and studying its environment, is essential to prepare us for this next big step in human exploration. Understanding the geology of regions like Inca City is key to identifying resources that future Martian explorers could use. For example, layered sedimentary rocks could indicate the presence of subsurface ice, an essential resource for getting drinking water, producing oxygen, and even for rocket fuel. The challenges of sending humans to Mars are huge, but not impossible to overcome. We need to develop technologies to protect astronauts from the strong space radiation and Mars's thin atmosphere. We have to find ways to grow food and generate energy on a planet with limited resources. And we also have to address the psychological and social consequences of long space voyages, of establishing a human presence on a distant world. Even so, the allure of Mars remains strong, driven by the possibility of scientific discoveries, the spirit of adventure, and the dream of someday turning this alien world into a second home for humanity. The footprints we leave on Mars will be the first steps towards a future in which our species becomes an interplanetary species, capable of living on several worlds and ensuring the long-term survival of our civilization. Section 1. An enduring Martian legacy. The allure of Mars, with its rusty hues and whispers of past waters, continues to draw us in, inviting us to uncover its secrets and understand its place in the grand story of the cosmos. We have journeyed from the enigmatic Inca City, a display of nature's artistry, to the layered history of Silver Mountain, where echoes of ancient lakes and rivers still resonate. We've seen the curious spheres of San Pablo Bay, each one a small mystery waiting to be solved. These Martian mysteries, far from being mere curiosities, are like stepping stones on our path to understanding not only the red planet, but also our own place in the universe. They remind us of the power of geology, the immensity of time, and the strength of life itself, which perhaps once existed on this now arid world. Every image sent by rovers like Perseverance, every analysis of the Martian soil, brings us closer to uncovering the history of Mars and its potential to have harbored life, perhaps even in forms we can barely imagine. Our exploration of Mars demonstrates human curiosity, our constant search for knowledge, and our desire to push the boundaries of what's possible. It's a journey driven by science, fueled by adventure, and with the hope of one day becoming a multiplanetary species, capable of inhabiting and even terraforming other worlds. As we venture further into the Martian desert, we carry with us the lessons of Inca City and other Martian wonders, the importance of observation, the need for skepticism, and above all, the capacity for wonder in the face of the unknown. The Martian chronicles are not over. They continue to be written now with each new discovery. And as we continue to explore, learn, and dream, we can be sure that Mars, the red planet, will continue to captivate our imagination, challenge our ideas, and inspire us to reach for the stars. The future of humanity could lie among the red dunes and ancient canyons of Mars, a testament to our exploring spirit and our thirst for knowledge.